Hello bachcho, let's read the question. So the question says air that initially occupies 0.280 meter cube at a gauge pressure of 103.0 kilopascal is expanded isothermally to a pressure of 101.3 kilopascal. Here the pressure is being reduced, hence the volume is being increased isothermally, and then it is cooled at a constant pressure until it reaches its initial volume. It then returns to its initial pressure in a constant volume process. Compute the net work done by air. So we are given with three processes. Let us write them one by one here. So the first process is isothermal. So delta T will be equal to 0, in which pressure from P1 is converted to P2, hence volume will also be changing. So here pressure is 103 into 10 to the power 3 Pascal, and here the pressure is 101.3 into 10 to the power 3 Pascal. Okay, now the second is cooled at constant pressure. So pressure is kept constant second time and it reaches its initial volume. Here the volume would have been changed V1 to V2. So from here the V2 will come back to V1, and in next it returns to its initial pressure at a constant volume. So in next stage it is volume is kept constant, hence P2 will come back to its initial pressure P1. So compute the net volume. So we have to find net work done by the air. Okay, so let us first revise the key concepts behind this question. So the first key concept behind this question is work done is given by integration of P dV. So this is the first key concept, and the second key concept is real gas equation, which says PV is equal to nRT. So these two concepts we keep in mind and jump right into our solution. So for solution part we have work done can be given as integration of P dV. From real gas equation we can write P is equal to nRT by V. So putting it in equation this, so we get W is equal to integration from V initial, which is V1, to V final, which is V2, into nRT into dV by V. So it gets equal to nRT is constant, it comes outside, nRT into natural log of V2 over V1. Now here we can write that P1 V1 is equal to P2 V2. This because temperature is kept constant. So P1 V1 will be equal to nRT. It will also be equal to P2 V2. Hence from here we can write V2 over V1. It will be equal to P1 over P2. So we can put this value in this equation. We get it equal to nRT. nRT can also be written as V1 V1 because we know their value. So P1 V1 into natural log of P1 over P2, because these all values are known. So now we can calculate their values. So we have initial gauge pressure, it will be equal to 1.03 into 10 to the power 5 pascals. Okay, now we can find the value of P1. So P1 will be equal to, so P1 will be equal to, P1 will be equal to 1.03 into 10 to the power 5 pascals plus 1.013, which is given to us 1.013 into 10 to the power 5 pascals. into 10 to the power 5 pascals. So this is the value of P1. Now we can put it in our equation which we have found. So we get the value of work done is equal to P1 comes out to be equal to 2.04 into 10 to the power 5 pascals into volume. So volume is given to us as 0.280 meter cube. We write it here 0.280 meter cube. So V1 is 0.280 meter cube into natural log of P1 over P2. So P1 is 2.04 into 10 to the power 5 upon P2 is 1.013 into 10 to the power 5 pascals. So 10 to the power 5 cancels each other out. On performing this calculation, we get it equal to 4 into 10 to the power 4 joules. So this is the work done in first case. Now in the next step, the pressure is kept constant. So work done formula comes out to be equal to P into V2 minus V1. Okay, so it will be P2 final pressure into V2 minus V1. So it can be also said that it will be equal to V1 minus V2, because in this case Vf is our initial, V2 is our initial state and V1 is our final state. So we have P2 into V2 minus V1 minus V2, and we can also say that V2 will be equal to P1 V1 over P2. So from here we can write P work done is equal to P2 into V1 minus P1 V1 upon P2. So on solving this, we get W is equal to P2 minus P1 times V1. So all these values are known, so we can calculate it easily. So it will be equal to 1.013 into 10 to the power 5 minus 2.04 into 10 to the power 5 into 0.280. Okay, so on performing this calculation, we get it equal to minus 2.88 into 10 to the power 4 joule. So this is our work done in second case. Now let us find the net work done. So it will be equal to W net, it will be equal to W1 plus W2. So this is W1 and this is W2. So it will be equal to 4 into 10 to the power 4 joules minus 2.88 into 10 to the power joules, 10 to the power 4 joules. So it will be equal to 1.12 into 10 to the power 4 joules. So this is the net work done after these cases by the air. So this is our final answer. Let's highlight it here. I hope you understood it well. Thank you.